The helicopter countermeasures include both active and passive types, contributing to high combat survivability in intensive enemy air defense fire, whereas the life-saving means are unparalleled among those existing today. The active countermeasures are aimed at early detection and warning the crew of radar types. To protect the crew from being hit by enemy missiles, they include radar and laser warners and flare dispensers against heat-seeking missiles. The passive countermeasures include cockpit armor plating, exhaust heat suppressors, fiberglass main rotor blades, and main fuel cell proofing. When flying over a battlefield, the helicopter becomes more vulnerable. In order to increase its safety, a series of measures was incorporated in its design, including spacing of engines apart to the helicopter sides to shield the main gearbox, whereas the outboard wings in turn shield the engines. Moreover, the engine spacing excludes their damage by a single missile. Single engine flying with automatic emergency power gain in case of one engine failure or damage. Throughout armoring of the cockpit, bulletproof laminated glass of pilot's and gunner's cockpit, armored bulkhead between crew members, minimizing the risk of 2 casualties at a time, armor plating of pilot's door and gunner's canopy door. The cockpit armor plating is proof against 12.7 millimeter rounds and 20 millimeter HE shells and rocket fragments. To suppress the infrared radiation, that is the heat signature, exhaust heat suppressors are installed. The main rotor blades of composite material remain operational throughout the flight after having been hit by 30 millimeter rounds. All main fuel cells are filled with polyurethane blocks and placed in self-sealing tanks that remain explosion-proof and leak-proof if hit by 7.62 millimeter and 12.7 millimeter rounds and fragments. As mentioned above, the helicopter life-saving means are unparalleled among those existing today. In case of a non-standard situation and or critical structure damage at the level of over 100 meters, an emergency escape system using the parachute operates. First, outboard wings and both cockpit doors are jettisoned. Then ballonets are inflated to prevent injuries to the crew by the undercarriage or slewed cannon barrel. The system can be activated both by the pilot and gunner. At the level under 100 meters, the crew survival is ensured by an ejection-free damping system with descent velocity of 15 meters per second. First, a seatback harness tightening system is triggered off to fix the crew members in their shock-absorbing seats. The initial impact energy is absorbed by the main undercarriage shock struts, then energy-absorbing seats that can bring 50 to 60 G loads down to 15 to 17. The so-called collapsing floor absorbs the remaining impact energy. Unlike the helicopters of similar class, the Mi-28N export variant has a compartment for 2 other helicopter rescued men. The helicopter has a fundamentally new main rotor system. Installed are new main rotor blades of the composite material, main rotor head, and X-shaped tail rotor for lower noise and higher efficiency. For the first time in domestic practice, lubrication-free elastomeric hinges were used in place of flapping, feathering, and drag hinges of the main rotor hub, and this resulted in lower maintenance costs. Other rotor head hinge joints have self-lubricating metal, fluoroplastic, and textile fabric bearings. Thus, the number of lubrication points was minimized. The The helicopter features a new transmission arrangement as a result of engine spacing and introduction of angle gearboxes. A new, more user-friendly main gearbox is installed. Other transmission parts are functionally similar to those of classical design helicopters and include transmission shafts, intermediate and tail rotor gearboxes. The undercarriage is of a tricycle type, having a tail steering wheel. What is special about the main struts is their longer stroke to withstand excessive loads and crash landing. The control system of the helicopter is of a classical type consisting of longitudinal, lateral and directional control, combined collective pitch and throttle control, and elevator control. The helicopter is fitted with an automatic control system that includes an autopilot to control the roll, direction, pitch, altitude, and airspeed. The latter is coupled to the navigational instruments of the helicopter. Because of the heavy armoring of the cockpits, no dual controls are installed in the gunner cockpit. The helicopter is fitted with a new principal avionics system for round-the-clock and all-weather deployment. The avionics system includes high-accuracy integrated navigation system, radar, day and night thermal imager for the pilot, day and night surveillance and targeting system for the gunner, 4 multi-mode liquid crystal displays, 2 for each cockpit, night vision goggles. Each crew member has a number of backup instruments for contingencies. The Mi-28N export variant has a high-tech inertial system to determine and indicate the helicopter attitude and provide signals for controls with any maneuver. The system also includes high-tech open architecture computers capable of expansion for more functions and any intellectual database or tailoring of incorporated functions to new specified environments. The high-accuracy mapping system with battlefield terrain digital data bank is installed in the rotorcraft. Using these data, the computing system can generate a three-dimensional map of the area where the helicopter is located. The self-test systems are incorporated throughout that enable the pre-flight and post-flight checks and fault finding to be carried out without the use of special testing and measuring equipment. This also enables a self-sufficient helicopter operation far from airfields and base facilities. So the Mi-28N export variant is an up-to-date competitive fighting machine capable of accomplishing various missions round the clock and in adverse weather conditions. The overall firing efficiency of the Mi-28N export variant is 1.4 to 1.6 times higher than that of similar Western makes. The firing efficiency of its turreted gun is 2 to 2.5 times higher, and the firing efficiency of its missiles 1.7 to 2.2 times higher. This information, based on specifications of systems and components of the helicopter, is to provide a general understanding of the design and capabilities of the Mi-28N export variant. More technical details can be provided upon request.